Welcome back to part of Geospatial Solutions. So in this tutorial, we're going to work on this least cost path analysis. So it is going to be a real world study in which we're going to apply this tool to solve a real world problem. Right? So we're going to work on this using the ArcGIS software. So let's get started with this. So I've opened my ArcGIS software here. Right? So first, let us see what we're going to do here. So first, in this case, we're going to use, so study area is going to be the Chamoli district of the state of Uttarakhand from India, right? So we're going to use this study area, right? So first let me add the shapefile boundary for this study area. So it is going to be Chamoli district of Uttarakhand state of Indian country, right? So it is, we can add the shapefile first. So it is going to be inside this folder. Right, so this is going to be my shapefile, right? So the thing here is that, so this place is basically a snow-covered area, right? So it is more prone to avalanches, right? So it is more prone to avalanches. So let's say we want to, let's say some person has stuck in those snow-clad mountains, right? And then that person is just demanding for someone to rescue. Right, so in that case, we're going to create two locations within the study area. Right, so that the first location is going to be the rescue team's office. Right, so let's assume that place as the source point. Right, so this team must travel to that place in which the person has been stuck. Right, to rescue that person. Right. So we're going to find out the least cost path from the source place, that is the rescue team's office, to the destination's place, right? So the place where the person is stuck, right? So this is what our main aim of this activity is going to be, right? So it is going to be finding out the least cost path from our source place to the destination place. Right, so I think it is pretty clear for you now. Right, so we're going to create 2 point shapefiles here, with the first one being named as the source point. Right, so the point where the rescue team's office is located. Right, and the second place is the destination point, to the place where the team has to reach to rescue that person of interest. Clear? So we're going to do this. So for that, we have to create 2 new point shapefiles. In this case, right? So I hope the sole objective of this tutorial is well understood here. Fine then. So as you can see, where the base map out here, right? So you can get a broad idea of our study area out here, right? So we're going to create 2 locations now. So first, let me go to the folder in which I'm going to create the 2 point feature classes. So let me get back to this folder of interest. So I'm going to create a new point shapefile as source. So it is going to be my source shapefile. So I'm just going to project my shapefile as well, so that it is going to be the projected coordinate system. So let me name it as source. So it is going to be a point feature type. So in this case, I'm going to give my projection EPSG code. So since my place is in the state of Uttarakhand, right? So this place falls under the zone number 44 of this UTM coordinate system. Right. So the code for this would be 32644. Right, so let me press enter for this, and then you'll be able to create a new source shapefile. Right, so I have to follow the same process for creating this destination shapefile as well. So let me right click on this folder of interest. So let me go back to this new shapefile. So it is going to be named as destination. Right, so the person where the place where my person is stuck, isn't it? So it is going to be this place. So it is going to be named as destination, right? The place to which my team has to reach, right? To rescue my person. So it is going to be destination. So the coordinate system is going to be the same thing, 32644. So let me press enter. So we can just create this one as well, right? So we have created both these 2 shapefiles, right? So now we can just populate those 2 shapefiles with 2 points, right? So it is going to be the source file first. So first, let me just start editing my source feature. So it is going to be edit feature, start editing. So let me just give So let me press continue here. So we can start creating a source feature first. So let me give a point somewhere out here. All right. So let's say my fire and rescue team's office location is somewhere out here. All right. So it is going to be somewhere nearer to my road, isn't it? So it is going to be here, right? So let's say this is where my place is, right? So I'm just going to give a point out here, and now I'm just going to give a point for my destination place, right? That is the place where my person is stuck. So it is going to be somewhere out here in a remote place, right? So it's going to be somewhere out here, right? So now let me give somewhere out here, right? So because you want it to be really remote, so it's going to be somewhere out here, right? So I created both these 2 points now, so we can just stop editing now, right? So it has been created, so you can save the edits and stop editing now, right? So it has been created now, right? So now we have to just build a cost raster, which we'll be discussing henceforth. So as you can see, I've just symbolized both my points with 2 different colors here, with my source point having the green color and the destination point having the red color, right? That is, it is going to symbolize the danger symbol, right? So now I'm just going to uncheck my topographic map here, right? So for that, should be enabling me to run my tools faster. So let me uncheck this topographic map, base map layer, right? So now it's time for us to build the cost distance raster, right? So for that, we have to include the cost attributes of our data, right? So this cost attributes, in the sense, it is going to calculate the total cost involved in reaching this destination point from the source point, right? So in this case, I'm going to build the cost distance raster by taking into account 2 important factors, right? So since this place is going to be a topographically varying place, right? So it is going to be having a lot of elevation differences. It is very important to take into account the slope of this entire area into consideration as a cost factor, right? Secondly, it is also imperative to take into account the percentage of snow cover, right? So the lesser is the snow cover, then more it will be easier for the team to reach my concerned point, isn't it? So for that, I have to consider the percentage of snow cover as well, along with my slope factor, right? So in this case, I'm going to consider both these rasters into account to create a weighted sum raster, and then I'm going to use that weighted sum raster as my cost raster to build my cost distance raster, right? So this cost raster is used to build the cost distance raster, right? So this cost distance is the representation of the total cost involved in traversing from my source point to the rest of the points of the entire study area, right? So in order to find the cost path from a source to destination, right? So the first thing is I have to calculate the cost distance raster from my source point to all the other points of my study area. Clear, right? So it is imperative to use these 2 factors in this case because it is based on my study area, isn't it? Because my study area is totally topographically variant, so it is the best suited thing to include the slope factor as well as the snow cover factor, right? So I think it is summing up to you now, right? So we can get started with them. Fine then. So we can add both those cost factors now, right? So I've already calculated those 2 factors for you, right? So let me just drag and drop those 2 factors into my map canvas. So as you can see, first let me add my slope of my entire study area, right? So we have to choose a path in which the slope is lesser, isn't it? So the more the slope is, the more steeper will be the terrain, right? So the more difficult will be the traveling for the team, isn't it? So it is going to be less as possible, right? So for that, we want to use this slope factor, right? So it is going to be added out here, right? So as you can see, I've already created it for you. So it is slope factor is the first cost attribute, right? And secondly, I've also calculated the NDSI, right? So the NDSI is the normalized difference snow cover index, right? So I've also calculated that for you. So I'm going to use that data out here. right? So as you can see, I've added both these two cost attributing factors. So I'm just going to use the weighted sum tool to create a combined weighted raster of both these two rasters, right? So let me create a proper symbology for these two things now. So it is going to be varying from, say, red to blue, right? So it is going to be varying like this, right? So it is going to be somewhere, so it is going to be having a smaller value, right? So as you can see, all the normalized indices, right, will be varying from -1 to +1, with the -1 to 0 indicating that it has got no presence or a very minuscule presence of the said parameter, right? So in this case, it's going to be the snow parameter, right? And then it is going to be from 0 to 1 that is going to be having a good cover of snow, right? So I'm just going to invert this thing, right, to create a proper snow cover data, right? So it has been created now, right? So next I'm just going to change my symbology of my slope data as well. So it is going to be having a default color ramp, something like this, right? So it is going to be varying between red to green, right? So it is going to sum up my slope elevation, slope angle differences rather, right? So I have added both these two things out here, right? So as you can see, all these places are totally snow clad, right? You can see it has got a good presence of snow cover out here, right? So as you can see, even my place, even my destination place is also covered in a good amount of snow as compared to my source place, because my source place is well within my mainland, isn't it? So it is going to be staying within my mainland. So I'm just going to use these two factors into account to create a weighted sum overlay. So before creating a weighted sum raster, we have an important thing to do here, right? So the first and foremost thing to consider in a cost distance raster is that it has to always be in the positive values, right? So we can't use a negative value to create a cost raster, right? For computing a cost distance raster later, isn't it? Right. So firstly, our input cost raster must always be in the positive values. That is, it has to vary from 0 to the positive values, right? So we can't have a negative value in our raster, using which we're going to create a combined raster, isn't it? So as you can see, our slope is fine, right? So it has got totally, it has got an entire range of positive values. But in the case of my index, right? So in the case of my NDSA index, you can see it has got some negative values, and these representative, these values are representative of the negative, I mean a smaller amount of snow cover, right? So it is well within the range actually here, but even in this case, we have to make some changes to this raster so that it is going to be used to compute a cost raster, right? So as I already told you, an input cost raster must always have the positive range of values, right? So for that, what we want to do now is that we want to reclassify this data set into, say, 5 classes, and then we want to combine this reclassified NDSI with this slope data to get a weighted sum cost raster, right? So this weighted sum cost raster is going to be used further to create our cost distance raster. Understood, right? So I hope you're understanding this concept of doing this reclassification thing out there, right? So it is entirely because of this negative value, right? Even though these values are correct, right? We are not supposed to use them to generate a cost distance raster. Understood, right? So for that, we are going to reclassify this thing further to get a proper format for a further process, right? Fine then. So we can start reclassifying our NDSA data now, right? So whether we have to go to the spatial analysis tools of my Arc toolbox, so we can use this reclassify tool to reclassify my anomalous difference snow index into 5 classes. So I'm just going to use 5 classes here, right? So you can use whatever number of classes you want to use, but I'm just going to go with the class. So it is going to, right? So it is going to be my NDSA image as the input raster, right? So it is going to take my value field of my raster's attribute table as the reclassification field. So let me change my classification number into 5, right? So it's not it's not like you have to compulsorily take this as 5, right? So it's totally up to your discretion. So this 5 is what I'm going to give out here. So as you can see, I've just classified the older values into 5 different classes, and it is going to be in the same values, right? So since we are going to compute a least cost path, the lesser the value is, the more will be its consideration for routing a least cost path, right? So it is correct as of now, right? Because the negative number values indicate that it has got little to no presence of snow, right? So it is correct to have these lower values to those ranges, right? So it is these places are going to be considered for creating a least cost path as compared to these larger valued places. Clear? So that's what we're going to use here. So it is going to be reclassified as classes 1 to 5. So let me save it in my folder of interest. So let me save it inside my least cost folder which I created earlier. So you can see that it is going to be named as ndsi underscore recl dot. That's what I'm going to save it. So it has been saved. So you can just click on OK to get the output. So it should take a while. Right. So it's running now. Right. So further we're going to use this reclassified data set to create a weighted sum raster by combining this reclassified data set with our slope data set. So further I'm going to go to this weighted sum raster, right? So in this case I'm going to add both those data sets. So it is going to be NDVA reclassified data as the first one, and then I'm going to use my slope data, right? So in this case I'm going to give my slope a slightly higher weightage as compared to my NDVA data, right? Because slope is also a bit more contributing factor to finding the least cost path. So I'm just going to give my weightage as say 1.5, right? So it is going to be 1.5 for slope data, and it is going to be 1 for the snow cover data, right? So it is going to be given as such. So we can just save this thing as say weighted sum dot diff, right? So I'm going to use this weighted sum dot diff as my input cost raster for determining my cost distance raster henceforth. Clear? So we should be able to get this thing. So it should take some while, right? So it has been created. As you can see, it has been created. You can see that it has got these values that are ranging only in the positive range. So we can now use the weighted sum raster which we have created out here to as the input cost raster for computing our cost distance raster. So we can go to the out toolbox again, right? So we have to use the cost distance tool, right? Within our distance tools of our spatial analyst tools, right? So you have to use this input cost raster, right? So that is a weighted sum raster as the input cost raster for this cost distance tool, right? So first I have to add my feature source data set, right? That is my rescue team's location, right? So it is going to be my green dotted point, right? So it is going to be my source point as my source shapefile. So it is going to be this one, and further it is going to be my weighted sum as my input cost raster. So it is fine. So we can just save this thing. So let me save this thing as cost distance dot diff as my cost distance raster, and further I have to save my backlink raster as well, right? So this backlink raster is important to find out the directions from the source point to all the other cells of the entire study area, right? So it is very important to for the software further on to compute our least cost path, right? So for that you have to feed in this data as well to compute our least cost path later on, right? So for that we will be needing this data set as well as the output for this tool, right? So it is useful to create the the directions from the source cell to the rest of the cells of the entire study area, right? So for that you have to need this data for further processing. So it is going to be saved again in my folder. So let me save it as backlink dot diff, right? So it is going to be saved, and then I shall press OK. So it is going to take some bit of a time for this because it is going to compute both these two data sets for you. So please be patient for this tool to run. right? So you can see these two outputs being generated out here, right? So the first one represents the backlink, right? So it is going to represent the directions from my source point, and this one represents my cost distance raster, right? So you can see these two outputs being generated out here, right? So we're going to use these two data sets further for creating our final least cost path, right? By using the cost path tool of the same toolbox, right? So we'll be going back to the ARC toolbox again. So you have to use the cost path tool now to generate our final output. It is going to show us the least cost path from the source point to the destination point, right? So we can just input our destination point now, right? So it is going to be the place where my person is stuck. So it is going to be my destination point here, and then so secondly, I'm just going to add my cost distance raster, which I have computed right now, right? So it is going to be my cost distance raster in this place. So it is going to be my cost distance raster out here, and then it is going to be my backlink raster that is going to represent the directions from my source cell to the rest of the cells. So it is the backlink raster here, right? So right, so that's it. So we can just save this thing in my folder of interest. So it is going to be saved something like this. So it is going to be LCP, that is least cost path from my source point to destination point. Alright, so that's it. We can just save this thing, and then we can just leave the other things as default. So it is fine to leave them as default. So we can just run this thing now. So taking some time for it to run. So you have to be patient again. So it has run quickly here, right? So as you can see, it has run quickly. So you can just uncheck all the other things in my table of contents, because I have to view only my lead, right? So let me just uncheck all these backlink cost distance raster as well as my weighted sum combined raster, right? So you can see, right? So you can see it has classified the data set into three different classes, right? So should you just zoom into this particular place, you'll be able to see, get a clear picture. You can see that it has given me a need line, right? So it has given me a least cost path from my source point to the destination point, and you can see these two categories. I mean, the categories 0 and 1 represent the no data cells. I mean, those things are not of any use for us here, right? So we're just going to reclassify this data further to get only the concerned path of interest, right? Because these things are unimportant to us, right? So there's no point in having them in our data set. So we're just going to further reclassify this data set to get only the third class, because the third class only represents our least cost path from the source point to destination point. So that is going to be our next step. Having the values 0 and 1 are not of any use for us, because they are the unclassified data, right? I mean, unclassified cells of the entire study area, right? So we're just going to use the reclassification tool to classify those two values as the no data values. I mean, the 0 and 1 as the no data values, and then this by third value 3 as the value 1 now, right? So it is going to be having only one value further, right? So it's going to be reclassified now. So for that, I'm just going back to my reclass tool again to reclassify this least cost path .tif dataset. So it is going to be that raster data out here. So it is lcp.tif. So as you can see, I'm just going to reclassify my old values. So it is going to be a no data value for the classes 0 and 1. I mean, the values 0 and 1, no data. So I'm just going to copy this text and paste it out here, further out here as well. Sorry, so it is going to be no data for both these two classes, and it is going to be 1 for my least cost path raster. So it is going to be named as such. So you can just save this thing, and for further processing, you can also check this box, right? Suppose if you're having any missing values, it is going to be renamed as a no data value, right? So it is also safe to check this process as well, right? So just for your own safety, so it is fine to check that box. So you can just save this thing as well as the lcp underscore final.tif, right? So it is going to represent only my least cost path henceforth. So it is lcp dot final dot to save this. So I'm just going to save this thing So it is going to give me a new output now. So you can just remove the older one now. As you can see, it has got only one class now, right? So we can just remove the older one, right? So we have almost reached the conclusion of this video. Now, the final thing is, right? So the final thing is that I'm just going to vectorize this data to show you the total length of this route, right? So that is what our final aim is here. Fine then. So finally, we have come to the final part of this tutorial now. So we're going to vectorize this least cost path raster to get the total length of this least cost path from source to destination, right? So for that, I have to go to my conversion tools of my arc toolbox again. So it is going to be a raster to polyline tool is what I have to use here. So it is going to be inside my from raster tool. So it is going to be raster to polyline tool to convert this raster into a line feature class. So it is going to be input is going to be my LCB final.tif data set, and then I'm just going to name this feature class as, again it is going to be .shp, right? So it is going to be shapefile. So it is lcp.shp as the final one, and then I'm just going to recode my background value as the no data values, right? So it is going to be the no data values, right? So the rest of the things are fine, so there is no need for you to change anything. So you can just click on OK to get the shapefile, right? So you can see it has given me a neat shapefile out here, right? So the final thing is I'm just going to compute the total length of this least cost path that has been arrived at. So we can just open the attribute table of this to add a new field to compute the total length of this. So first let me add a new field saying distance. So it is going to be in the bubble type to get a more accurate value, right? So it is going to be the point values. So you can see it has been created now. So you can go to this field, right click on it to this calculate geometry property, right? So it is already in the PCS format, so it is fine. So you can just change this unit kilometers, right? So that's it. So you can just click on OK. So you can see it has given me a total length of 39.42 kilometers, right? So you can also reduce the total number of decimals of this by going to the properties, then go to the numeric box to reduce it to see 2 decimal digits. So you can just get a broad value. So you can see it has got a distance of 39.42 kilometers. This is the right. So this is the least cost path analysis to find out the least cost path post point to destination point. So I hope this video was of some use to you. Please subscribe to my channel, friends. So it will be of so much help for me, right? So please do that. So we shall meet again with a very nice concept, right? So thank you so much for watching. See you then.